Thanks.
Good morning, everybody, and welcome to our session on HACCP. Thank you to Tracy and Mairead and to SafeFood for inviting me to today's event. Just a little introduction on myself. I've been working for the food industry for over 30 years, and for the past 25 years, I've been working the role of consultancy and training. Through this time, I've witnessed many good examples of effective application of HACCP principles. However, I've also encountered many examples of when HACCP just hasn't quite worked, and I hope to be able to guide you through some of these pitfalls today. I've worked in both small and large-scale food processors and manufacturers, as well as storage and distribution sites, catering both in small and large, for example, hospital catering. And I'm also fortunate to work in some associated businesses, such as food packaging and animal feed. And I've been able to assist them apply the principles of HACCP in their industries as well. HACCP is a system which I believe can cause great apprehension among those starting their journey. However, please don't let the jargon put you off. And I hope to take some of the mystique out of HACCP for you today and guide you through the process to enable you to successfully apply the system in a manner which will benefit your business and also ensure a robust food safety control system. It's a well-known and well-practiced food safety management system, and it's important that at this early stage in the presentation, they make it very clear that it's managing food safety and not quality. You will likely have many more quality concerns in your business than you do food safety, so we want to make sure that we focus our HACCP plan on food safety. So we don't want to muddy the waters and use HACCP only, as I say, for food safety only. So in 2021, we're very aware of food safety culture. This, however, is nothing new. It's found a new voice in recent years, but it's been around for some time. So what do we mean by food safety culture? It's what we do as a business. The culture is embodied by the beliefs and values within your company, and HACCP and food safety management is very central to this. HACCP is a system which will achieve good food safety culture within your business. Behaviours to food safety control will be driven by the values and standards that you set as a senior management team. It's therefore important that you communicate these and lead these from the top and ensure that they are achievable, providing the necessary resources. You have a responsibility to ensure the culture is being achieved by monitoring, verifying, and reviewing. So we need to lead from the top. And as you can see in this little diagram, the values and beliefs are underneath the water. And at the top, our iceberg, we've got our behaviours coming through. And this is very, very important. So what are the benefits of a business of having a good food safety management system? In other words, having a HACCP plan in place. Well, first of all, it's a preventative systematic approach. It should help you identify all currently conceivable hazards, including those that have not yet occurred, but can realistically be predicted to occur in the future. Let's prevent making unsafe food rather than having to react when we have produced unsafe food. It should assist us in increasing confidence in our product safety. And this is being able to identify any areas of concern where failure has not yet been experienced, particularly useful for new operations and thus giving you the confidence that you are in control. It's a good, effective use of your resources because we control our control can move from end product testing which was, for example, testing for failure, and move it into the design element and the manufacture of our process. So we're preventing failure by ensuring that we have thought through in our process how we're going to do that. It's a cost-effective control of foodborne hazards, making sure that we focus technical resources in the critical parts of our business. For example, we can focus some training and key parts of our process, perhaps of our CCPs or our prerequisite controls, and make sure people are appropriately trained in these areas. Or indeed, we can look at maintenance of equipment and we can focus on the key pieces of equipment that are necessary from a food safety perspective. From a legality point of view, there's a number of things that we can do. So under European food law, we must ensure that we have food safety management controls in place. Under 852/2004, the Hygiene of Foodstuffs, under Article 5, it states that food business operators shall put in place, implement and maintain permanent procedures based on HACCP principles. And these pretty much mirror the Codex HACCP principles that we're going to look at this morning. From a due diligence point of view, it's a system of control that has been fully implemented and maintained. And if we're able to demonstrate that it has been implemented, that it has been maintained and kept up to date and verified, then we can use this as a source of information from our due diligence defence. It also helps inspections when they happen, because they can actually use the HACCP plan as the central focus for their audit, and they can use the flow diagram and walk the process through using that. It also demonstrates management commitment. So it covers all aspects of the production from raw material, growing, harvesting, right through processing to the final product. And if we have a decent HACCP plan in place, then it shows that we have good management commitment. I'm a great believer in HACCP. However, on occasions, HACCP doesn't work. And when is this likely to be? Well, caused by lack of knowledge by those carrying out the HACCP study, perhaps by not completely implementing the principles correctly, or not implementing the plan correctly after they have designed it, not keeping it up to date, so lack of maintenance, not reviewing it, perhaps not using a team approach, relying on a student on placement to carry out the study, missing out significant hazards in the design stage, buying in a generic plan, not all hazards being identified or not being appropriately controlled, wrong or incorrect monitoring procedures or not following the monitoring procedures, lack of training, lack of understanding. So perhaps having a paper-based system which is not actually carried through within the factory. This can lead to a false sense of security. And we may believe that we have a good system, but actually it's not working in practice. We might not keep the system up to date, so there could be new hazards that have emerged that we're not aware of, or changes to process that we have not considered, which could, of course, be introducing a hazard, or could be removing a hazard. So there's lots of pitfalls, and it's much better if we understand what the pitfalls may be, and then we can try and avoid those pitfalls. This is a model that I have developed over the years to try and describe the hazard analysis process. And then it's going to be a summary of what we're going to look at today. So I see HACCP as a bit of a filtration process. So in at the top, we throw in what are the hazards that we may be considering. Okay, so at this point, we throw in all our potential hazards, and then we ask a very simple question. Are these food safety? If they are quality hazards, we can leave them behind, but if they are related to food safety, we bring them through to the next level. So we've now reduced our pool of hazards down, and we only have food safety hazards pulled through to the next level. So now we need to decide if they're significant. And we do that by a method of risk assessment that we will cover a little bit later. So if they're not significant, then again, we don't particularly need to be worrying about them, but if they are significant, we pull them through to the next level. And once we get to this level 3 in the process, this is where I believe it's very important. So we now have significant food safety hazards. And Codex tells us that all significant food safety hazards must be controlled. So the first question we ask here is, are these already being adequately controlled by prerequisite programs, or indeed operational prerequisite programs if you're using that term? So if they are, then we will cross-reference them out to the prerequisite programs which are controlling them, and we will do a gap analysis to make sure they're appropriately controlled. If not, we'll bring them through to the 4th level. So at this point, we have significant food safety hazards, and they're not already being controlled by prerequisites or operational prerequisites. So at this stage, we must ensure that there are adequate controls in place. So we will have to introduce a control at this point. And then we ask a final question, are these critical control points? And if they are, they drop down to our final triangle at the bottom, and we have identified critical control points. If they're not, and they're left behind, they're still significant, and therefore they must still be controlled. And we would need to make sure that we've got adequate control measures in place. I mentioned in the values, iceberg values, that we need to have management commitment. So it's very important that we gain and maintain management commitment from all levels within the organisation. So from the senior management team and also from middle management as well. What do they need to know? Well, what are the food safety objectives of the business? And very importantly, what are the consequences if we lose control of food safety? How does HACCP relate to other systems, for example, other quality management systems that you might have in place? And you will find a lot of the controls you already have in place under your QMS systems will fall into our prerequisite controls. What's involved in setting up a HACCP system? Who should be involved? How long roughly is it going to take? And what resources do we need? Do we have these resources in place, or do we need to buy in these resources? Time is one of the biggest resources that we need to manage. So when somebody is committing to this, it's very important that they realise that they're committing to a long-term project. So what are we going to pull together? We're going to pull together something called a HACCP plan. And a HACCP plan includes a lot of information. It may not all be stored in the same file, but we will have this information. So we normally will have a bit of a company description and background. We will refer to the appropriate legislation and any codes of practice that we're following. We will have the scope of our study, a descriptor of our product and our raw materials and our process. We will identify the intended use of our product, because that's going to have an impact on the hazards of concern and why are we concerned about them. We will map out our process, and we will have a process flow diagram or diagrams. We will have hazard analysis and risk assessment documents, justifications in the form of team minutes, the discussions that we've had. We will have the CCP decision tree process and answers. We will have control charts for our CCPs and procedures in place for both our CCPs and our prerequisite programs, and also monitoring for both of those as well. So we recommend that you follow the Codex Alimentarius principles. And Codex Alimentarius is a collection of standards, guidelines, and codes of practice which have been adopted by the Codex Alimentarius Commission. The HACCP piece of text, which is the food hygiene text, was last updated in November 2020, and it had been some time before this latest update, and we had been waiting for it for some time. And there's some significant changes in the 2020 document. The picture that I have up there is the issue 4, and we don't have a nice colour picture, unfortunately, of the new document as yet. So Codex is central part of the joint FAO, Food and Agricultural Organization of the United Nations, and the WHO, the World Health Organization, as part of their standards program. They first met in 1963, and they have 188 members, and their aims are to protect consumer health and to remove barriers to trade. This facilitates international trade in a safe manner. They first created their HACCP principles back in 1992. These were updated in 1997 and again in 2003. And then edition 4 was published in 2009 with just small admin changes. But we have seen quite a major change in the document in 2020. So there are 7 principles that we follow. The first one is conducting a hazard analysis. And when we conduct a hazard analysis, we identify potential hazards. We risk assess and identify the significant hazards of concern. And once we've identified those significant hazards, we implement control measures. We then try and determine the critical control points in our process. For these, we lay down parameters for them to work within, which are known as critical limits. We then need to check that we're working within those critical limits, which is monitoring. And then on occasions, when monitoring shows that our critical limits are not being achieved, we put in place the appropriate corrective action. We then have our final 2 principles, which are around verification procedures. In other words, maintaining and making sure that our HACCP remains valid, and then record keeping and documentation. And these are all very important principles to follow. If, however, I was to give you these principles and suggest that you carry out HACCP based on that, you may struggle. So they've broken it down into a further 12 steps. And the first 5 steps are known as our preliminary stages. So assembling a HACCP team, describing your product, identifying the intended use of your product, constructing a process flow diagram or diagrams, and then confirming those are correct. And then we follow on with the 7 principles. I have 2 that I would like to add to this. Right at the top, we have defining our scope in terms of reference, and at the end, we would add on review. So whilst these are not strictly Codex, it is very well documented that we do need to define our scope in terms of reference and that we should have review. And in fact, review is mentioned in our European legislation, so it is important that we have review included within there. Okay. So I'm going to start with the HACCP team. You may need to define your scope to determine who is on your team, or you may need to have your team there to be able to define your scope, but they happen fairly simultaneously. So we need a team. We work with what we call a multidisciplinary team. In other words, people from different parts of our organization. Our core team is normally made up of production, quality, or technical and engineering. And then we will have co-opted team members as and when we need them, sometimes known as ad hoc members. I have written HACCP plans on my own, and when I look back at them, the results were very much skewed from a technical QA point of view. So it's certainly very important that we have people from different parts of our organization. Particularly useful when your process goes through different departments, it's very useful then to have people from different departments on your team. It's also good to have different levels within the hierarchy of your business on the HACCP team. So people who are senior enough to have the authority to make decisions, but also include some supervisory level staff who are going to help you implement the plan. And you may even bring some key operators onto the HACCP team as well. Once we've had our team, or maybe before you set your team, as I said, quite close together, we're going to define the terms of reference and scope of your study. So what hazards am I going to look at? What is the product that I'm going to look at, or products, or am I going to do it by process line? So by hazards, we've got microbial, physical, chemical, allergenic, malicious, and fraud. So am I going to look at all of those hazards, or am I only going to be concentrating on a few of those hazards? What is the scope of the study? So where is the starting point and where is the end point? So starting point is normally at the point of intake of raw materials, and the end product is normally at the dispatch of our goods. But if you're involved in catering, then your end point might be service right to your customer. If you're transporting your own goods, then you would include that within your scope. If you're using third party transportation, you would include them within your prerequisite program. Purchasing of raw materials is normally down as a prerequisite control. You might be grouping products together within your scope, or you might be carrying it out by a process, so one defined process from start to finish, or you may be using a modular approach. And a modular approach is where perhaps you would have goods in and storage as one module, and then you might have preparation as a module and various process steps, and then maybe have packing as a module at the end. So whatever works best for you can be followed through on. We then need to describe our product, and in order to carry out our hazard analysis effectively, we need to gather product and process information. So composition, for example, what is the recipe? What are the raw materials that are going to be used? What are the ingredients, and what are the origin of these ingredients? There may be what we call recipe or intrinsic control factors. So that might be naturally occurring pH levels, water activity levels, which may have an impact on microbiological hazards being able to survive or indeed grow. What are the processes? What are the principal process technologies? So what processes do my food go through? Do they go through any form of heat treatment, any other preservation technique? Are they capable of removing the hazards in the process, or are we introducing hazards by my process? So we could be introducing from a piece of broken machinery or from people handling the product. How is my product packaged? Is it aseptic packaging? Is it vacuum packed? Is it modified atmospheric packing? That could well have an impact on the safety of your product as well. What are the storage and distribution conditions? Ambient, chilled, frozen? And what is the proposed target shelf life? So in these early days, you would want to know this information. As well as that, you would maybe want to know, are there any allergens present in any of my raw materials? So understanding any that might be present already. We need to identify the use of our product. And here we're thinking about what is going to happen to your product after you've produced it. So how is my product going to be used? Often this can be identified incorrectly because people think that they're supplying, for example, pasteurized eggs, and they're thinking the end consumer may include all the vulnerable groups. In fact, they're supplying to a processor who will then fully process the product through a heat treatment and should destroy any of the harmful bacteria. You need to consider your target group and particularly your vulnerable groups here. Okay, so do you supply into hospitals, into care homes? Are you providing product for children? Remember, a child will choke on a much smaller foreign body than an adult will. So really think about the type of product that you're producing and the vulnerability of those included. We also include allergen sufferers now in our vulnerable group, and particularly if you're making a claim that your product is free from a particular allergen, then it would be important that we include that within our target group. What are the instructions for use? How clear is it that the consumer knows what to do with the product once they receive it? Does it have to be fully cooked before consumption? Does it need to be stored in a particular way? What is the shelf life? And then consider abuse potential. So misuse, perhaps not not cooking it properly, not storing it properly, or perhaps using it for an alternative use. For example, flour is intended to be baked in the product. However, a lot of people take flour after they've baked the products and sprinkle flour on top of the products, and that is not how the flour is intended. And therefore, potentially there could be microbial contamination if it hasn't gone through that heat treatment. So once we've gathered our information, we can move on to our prerequisite programs. And prerequisites are a relatively new addition in HACCP in recent years, but a very welcome addition. So here we're starting to consider what are the existing general food hygiene controls that we already have within our business. And they were not referred to in Codex until the recent change in the document in 2020. They were alluded to, but they were not actually mentioned. So let's look at a couple of definitions. So the World Health Organization definition from 1998, practice and conditions needed prior to and during the implementation of HACCP that are essential for food safety. The Codex definition is quite long-winded. Programs including good hygiene practice, good agricultural practice, and good manufacturing practices, that as well as other practices and procedures, such as traceability, that establish the basic environmental and operating conditions that set the foundation for implementation of a HACCP system. So if you look at the bottom part of that definition, it's the basic environmental and operating conditions that set the foundation. So they deal generally with site-wide hazards. They deal often with repetitive hazards. In some occasions, they can deal with lower risk hazards and, dare I say it, quality hazards. But they tend to be hazards associated with the environment, people, fabrication, and facilities such as machinery. But they are not specific to a particular process step. So we would include things like pest control, personal hygiene, staff training, approved suppliers, control of waste, control of water, PPMs on your equipment, workflows, fabrication, supervision, calibration, control of chemicals, sometimes control of allergens. So it can be a very, very wide scope of parts of a process that we include. And these are our basics. And I often talk about the importance of getting back to basics. If we can get our basics right, then the rest should follow suit very nicely. So with our prerequisite programs, they need to be able to control hazards that we've identified. So often in our hazard analysis, we will state that the hazards are adequately being controlled by prerequisites. And when that is the case, we then need to do a gap analysis of our prerequisites to demonstrate that the prerequisites are adequately controlling those hazards, sorry. We need to validate them, okay, prove that they work and that they are robust enough. We need to have a procedure in place for every prerequisite. We need to train our staff against the prerequisites that are appropriate to them. And a lot of staff are going to need to be trained in all prerequisites. We need to come up with a method of monitoring our prerequisites to ensure that they are being followed and indeed verifying them as well. So it's a long-term commitment, making sure that our prerequisites are working, and then review them. If we look at the Codex General Principles of Food Hygiene document, they have broken down their document into the following sections, and each of these are really prerequisite controls. So we have primary production, and that looks at environmental hygiene and hygienic production of food sources, handling, storage, cleaning of those primary production areas. So we're thinking there about live animals, we're thinking about raw milk, we're thinking about fisheries and vegetable processing as well at the field level, okay? We then move into our processing, where we have various establishment sections. So we've got design and facilities. So here we're looking at the location of the site, the premises, the fabrication, the equipment, the rooms for food prep. We have training and competence of our staff. So what training programs do we have? How do we instruct our staff? How do we supervise our staff? What refresher training do we have as well? Under establishment, then we have maintenance, cleaning, disinfection, and pest control, and also that includes control of waste. We then have personal hygiene, so health status of our employees, how they report illness and injuries, personal cleanliness, visitor programs, and an interesting one there is personal behaviour. And that links very nicely back to our food safety culture. It's the behaviour that staff have. It's not just enough to train them in personal hygiene procedures, it's making sure that people want to do it and that they morally will follow the correct procedures, not because you've told them, because they realise the importance of them. We then have control of operation, so looking at how we bring in our raw materials and the checks that we do, packaging that we use, making sure that that's adequate, control of water, supervision of staff, documentation and records, ID and recall, ID and traceability and recall, product information and consumer awareness. So what do we have on our packaging? So lot IDs, product information, which may include cooking instructions or storage instructions, labelling, including allergen labelling, ingredient declarations, all our legal labels and weights, and any other consumer education that we might be trying to communicate through our packaging. And finally, transportation. And that might be third-party transportation, it might be your own vehicles, but it may even be in-house transportation through your process. So it's quite a good idea to take these Codex principles of food hygiene and look at these from a point of view of setting your prerequisite controls around them. So once we've gathered those, we can move on to mapping out our process. And this will assist us in carrying out our hazard analysis at a later stage. So our flow diagram needs to be suitably detailed, otherwise we run the risk of missing some hazards when we carry out our hazard analysis. So our process flow diagram should include all our raw materials. If you want to group your raw materials, just be careful that if you are doing that there isn't maybe a specific hazard, for example, an allergen present in one that maybe isn't present in the others. So just to make sure you're adequately controlling them. It should include packaging as an input, and if you're using any utilities such as water or steam or gas, compressed air, then those should be shown as an input as well. How are each of these being stored? And how do the process activities happen? Okay, so all the steps, including decanting, weighing, all your various process steps, how they link in with the previous step and how they link forward with the next step. I find that if simple flow diagrams have been developed, then the hazard analysis results in being pretty inadequate. So make sure your flow is suitably detailed and verify it. Okay, check that it is a good reflection of how you produce on every shift pattern. Okay, check it out in various shifts. If you've got waste, and you will have product waste on occasions, and you'll certainly have packaging waste, show that coming off as an output. If you have low and high care areas, clean and dirty areas, then I would put a line in my flow to show when it transfers from a low care into a high care area, for example. If you have any subcontracted work, then show when that goes out and when it comes back in. And don't forget to include rework and recycling. People often ignore those steps. But if you have rework, and on many occasions we will have rework, then show how they're managed, okay? And it will then get you to actually manage those steps. You need obviously to verify your flow before you do your hazard analysis. So walk the flow and make sure that it's accurate. That then brings us to our hazard analysis stages. So here we're going to identify potential food safety hazards. We're going to risk assess, and by risk assessing, we're going to pull out what we call significant hazards. In order to risk assess, we're going to look at the likelihood and the severity. So for each step in our process, we're going to identify potential hazards, we're going to risk assess and identify our significant hazards. So we're looking at potential food safety hazards and consider under each category. We're going to then look at likelihood and severity and identify the significant ones. And Codex says all significant hazards must be controlled. So we're going to then review our existing controls and see if these are adequate. And they may be existing prerequisites or operational prerequisites. And we're going to document those down. If they're not, then we will need to identify additional control measures that need to be put in place. So what is a hazard? Definition of a hazard is a biological, chemical, or physical agent in food with the potential to cause an adverse health effect. In other words, it has the potential to cause harm to the consumer, either by causing poisoning, such as food poisoning or chemical poisoning, or causing some level of injury, so physical, causing a choking injury or injury to breaking a tooth or cutting your mouth, or it can be caused by an allergenic reaction. So when we're carrying out our hazard analysis, we're considering these hazards that will cause harm to the consumer. And remember, these may be variable depending on the vulnerability. So as I said earlier, a child or an elderly person may choke on a smaller foreign body than a healthy adult will. If we're worried about something like listeria, then we'd be particularly worried about the elderly, the very young or pregnant women. So it's important that we understand the vulnerability when we're doing our hazard analysis. Can I caution, this is not health and safety harm. This is not about somebody tripping or slipping or falling. This is about the harm to the person who's going to consume the product, okay? So health and safety is very important, but it's not included within a HACCP system, and often people mix the two up. So if we look at these hazards, biological can be broken down into microbiological, and we particularly worry about our pathogenic bacteria, which are our harmful bacteria, the ones that cause food poisoning, but we can have other biological hazards as well. So we can have viruses, we can have various ones out there, like parasitic problems as well. So there can be other biological that are not microbiological. Chemicals, then we worry about cleaning chemicals, dioxins, veterinary drug and antibiotic residues, but we also look at radiological hazards now as well within the chemical section. So with pathogenic bacteria, that's likely to be coming in your raw materials, and you need to then think about what is the process that you're doing. Are you going to remove those pathogens during your process, or indeed such by heat treatment, such as pasteurization, or indeed am I introducing microbiological hazards during my process, perhaps by unclean equipment or people handling or pest contamination. So what are the chemicals that are likely to happen? I think they're probably one of the most poorly managed hazards around, because we don't know enough about them, and we tend to worry about cleaning chemical residues, but there are lots of others such as pesticide residues, veterinary drug residues as well. And then Physical, as I said, something you're going to choke or cut your mouth or break your tooth. And then we have added, and this is not in our definition from Codex, allergens. And the reason allergens have not been added into their definition is that there's not defined trigger levels as yet for all allergens around the world. And this is an international standard. And therefore, they have mentioned a lot in the 2020 Codex document around control of allergens. So they've certainly identified allergens as a potential hazard, but they haven't included them within the definition. So are they naturally appearing in your product? In other words, they're intentional allergens, or have we allowed cross-contamination from unintentional allergens through our process? And then we have a bit of a controversial one here at the end, which is malicious contamination and fraud. So malicious contamination and fraud are what we call intentional hazards, whereas the rest of our HACCP hazards are unintentional. And so these malicious and fraud tend to fall into our vulnerability risk assessments. However, a lot of the retailers and some of the GFSI standards have decided that they would like these included under HACCP. So we are now including them as a potential hazard under HACCP. I personally believe they should be under vulnerability systems and not under our HACCP system. But as the GFSI standards and some of the retailers are asking for it, then we are considering them at every step in our process as well. So fraud is most likely to happen at intake, raw material, and then malicious could happen at any step where I suppose people have access to your process, and it might be where product is exposed. We need to accurately define our hazards, and this is what we call the manifestation of our hazards. And we need to accurately define them. So we've got presence, contamination, multiplication, and survival. So is it naturally present in, for example, the raw material, so it's already there? Has the is the hazard there due to contamination, cross-contamination, which normally would be during our process? Have we allowed it to grow to significant levels, which is causing harm, so multiplication or growth? Or have we allowed the hazard to survive a process which has been designed to kill the process? Okay. And the more specific I can be when I define my hazard, the easier it will be for me to identify my controls. So if I'm looking at microbial hazards, I could be preempting it with any of these words. So I could have presence of E. coli in some raw meats coming into my premises. I could have cross-contamination with E. coli from dirty surfaces. I could have multiplication of salmonella due to temperature abuse during storage. I could have survival of E. coli or salmonella due to ineffective heat processing during a cooking process. So what I'm doing here is thinking about the manifestation. I'm thinking about the cause or the source of the hazard, and that makes life a lot easier. So if I'm worried about growth of salmonella due to inadequate storage of my product, then I know what I need to do is control my temperature, control of my storage. If I'm worried about cross-contamination with salmonella due to dirty equipment, then I know what I need to do is do my cleaning. Okay, so it really helps the more detail we can put in there. So if I was looking at microbial, any of those four could be there. If I was looking at chemical, it's mainly going to be cross-contamination. Could be presence in raw materials, so you could have presence of pesticides, but that would be due to common cross-contamination at the field. If I was looking at physical, then again, it's mainly cross-contamination from, say, nuts and bolts falling off in the process, but we could have physical contaminants present coming in. Okay, so we have what we call intrinsic, or we have extrinsic physical contaminants. So intrinsic means it belongs to the product. So maybe a piece of chicken bone coming in with our chicken, it belongs to the chicken. Whereas if we had a stone coming in a vegetable, it doesn't belong to the vegetable, therefore that's an extrinsic. So presence could be there coming in due to naturally present or due to cross-contamination. There's an interesting product recall in recent months with a baby food where they had apple stalks had got through into the baby food. So that is an intrinsic physical, it belongs to the apple, but we wouldn't want the apple stalk in that product, and it then constituted a choking hazard because of the vulnerability of the people that were going to consume that product. If I was then looking at allergens, It could be typically present, so it's naturally present, it's intentionally present in that product. It could be down to cross-contamination, where an allergen from a production line gets transferred to another production line, okay, to another product on that line. Or it could be survival, in that it has survived a cleaning process that's designed to remove that allergen, okay? So it is very dependent on the hazard that you're looking at. So we carry out risk assessment and we use the criteria of likelihood. So how likely is it that the hazard would happen, and without control. So if we didn't have controls in place, how likely is it that this hazard would occur? And then severity, if it did happen, what level of harm would there be caused to the consumer? And from that, we identify what we call significant hazards. So when we're carrying out our risk assessment, we need to consider the likely occurrence of the hazard, the severity and the effects on the consumer safety. So taking into account the vulnerability of those exposed and who your target audience is, the survival and multiplication of pathogens, the presence and production of toxins and chemicals, contamination of raw materials, the potential for adulteration, and you need to have sound information to help you do this. So we use weighted systems very similar to health and safety, and we can use simple words to help us. And this is what we call a 3x3 matrix. So I've got 3 criteria under likelihood and 3 criteria under severity. So I could have a low likelihood with a low severity, a low likelihood with a medium severity, a low likelihood with a high severity. Then I could have a medium likelihood with a low, medium, or high severity, and then a high likelihood with a low, medium, or high severity. So if I was to use that, it can feel a little bit subjective, but having your background information is really important, and having the right people on the team. So it's quite easy to work out the first one. So low likelihood, it's not likely to happen. Even without controls, it's not likely to happen. And if it did happen, the level of harm is very low. So I can easily say that's not a significant hazard. The bottom one, it's highly likely to happen. And if it did happen, the level of harm is very high. And that would therefore come out as being significant. It can be a little bit difficult to try and ascertain with the other ones. So you need to define, what do I mean by low, medium, or high? So low might be, it's never happened under likelihood, or it's very unlikely to happen. Medium might be it's happened, but not very often, but it could happen. And high is it's happened lots of times, or it's highly likely to happen. Severity might be low is slight discomfort, medium might be food poisoning, high might be death. So you have to define what we mean by each of those. You can use a 5x5 matrix, a 10x10 matrix. It's entirely up to you what you use. There's no hard and fast way of doing this. But instead of using words, I use numbers. Then I end up with 1 being for low has a number 1, medium has a number 2, and high has a number 3. And I multiply across. And so my scoring comes out as 1, 2, 3, 2, 4, 6, 3, 6, 9. 1 being my lowest score, 9 being my highest score. And within that, the midpoint would be 4.5. So we don't have a 5 possibility in our multiplications out. So we would normally go 4 and above is significant. Okay, so it's an easier way to risk assess rather than just using the words with that one. Okay. It's important to have the right people in the team to do risk assessments properly, so that we get the right outcome, okay, that we do consider the significant hazards. Once we've done that, we then put in place controls. So a definition of a control is any action or activity that's used to either prevent or eliminate a food safety hazard or reduce it to an acceptable level. So we don't always have to prevent it from happening or remove it. Sometimes reducing it down to a safe level with a microbial hazard is sufficient. So that might be by cooking it, or we might be removing it by maybe using a filter or a sieve, or we can try and prevent it from being there in the first place. So controls are often a lot of the prerequisites that we already have in place. So that could include things like effective storage, it might be heat processing, it might be staff training, it might be different policies that we have. So a lot of your controls may be identified as being prerequisite controls, but it's important that if we do identify them as prerequisite controls, that we then go back and that we check that those prerequisite controls are robust enough and that they actually deal with the hazards of concern. So once we've identified our significant hazards and controls, we can then move to identifying where are the critical control points, if any. So CCPs are a step where control can be applied and are essential to prevent, eliminate, or reduce a food safety hazard to an acceptable level. It's very similar in definition as a control measure, but it's saying that it's essential at this step. So the CCP always applies to a step in the process, and it's usually the last point in the process where we can control a particular hazard. And what we do then is put the step through our decision tree, and we have a series of yes, no's, and it will either tell us that it's not a CCP or it is a CCP. If we put prerequisites through the decision tree, they tend to come out as being critical. So my recommendation would be that if you are sure that your hazard is being adequately controlled by an existing prerequisite, then you reference out to that prerequisite, you make sure you've got a procedure there and that you have ways of monitoring that, and then you don't put it through the decision tree. So for our CCPs, and we are seeing a trend of a lot less CCPs, so a lot of manufacturing sites will have 1 or 2 CCPs, some don't have any. Catering will maybe have a few more CCPs. For those CCPs, then we lay down parameters for them to work within, which are known as critical limits. So a criteria that separates acceptability from unacceptability, safe product from potentially unsafe product. It needs to be something which is measurable, preferably by a test, and must relate back to the hazard and its control. How do you set those limits? You may be able to set them using scientific information, or legal requirements might be available for you to set your limits, or industry best practice. You can use something called a target level, which is more stringent than your critical limit. And these are particularly useful if you're monitoring against a target level. They buy you that little bit of time, a bit of a buffer zone. So it allows you then to take action before the critical limit is broken. Okay, so that stops you getting to that point where unsafe product has been produced. So once we've set our critical limits and or our targets, if you're able to use them, we need to check that we're working within those limits. And this is known as monitoring. So again, you can see where the jargon comes in and can be very confusing. So monitoring is what we do to check that the control measure is working and that we're working within the defined critical limits. So definition, conducting a planned sequence of observations or measurements of control parameters to assess whether a CCP is under control. So there's different types of monitoring that we can have. We can have continuous online, which is probably the best type of monitoring. So we're continuously getting a readout. And we can have batch monitoring. So instead of having continuous, we maybe are doing a check several times per day. So you have to decide on what is the appropriate frequency for those checks. We need to define who is going to be responsible for monitoring. If there's any monitoring equipment, then we need to make sure that is appropriately calibrated and in good working order, and having backup devices as well. Where are we going to record our monitoring information? So having record forms developed for that. We need to have a procedure for our monitoring, procedure for our CCP, and we need to verify that our monitoring has been carried out effectively. So we need to ensure that our monitoring is capable of detecting if there is loss of control. So it needs to be a very robust system. So continuous online monitoring, such as data loggers, are very, very useful. And this is where we start to think about record keeping as well. Records are proof. Records are proof that we've produced a safe product, but they can also be used as our due diligence defense. So should something go wrong down the line and you have to then prove your due diligence, your monitoring records are going to be extremely important. So you need to make sure that your monitoring records are accurate, that they are being carried out at the time by a trained person, and they're an honest reflection of the check that they've carried out. And so if they are maybe made a mistake, then it's important that we remind them to put a line through it, initial it, and then put the correct figure in, and not to scribble over the top of records, because these are permissible in court and they may have to be shown as evidence. And if they're scribbled all over, then they're not going to be very useful evidence for you. So monitoring generally will demonstrate that we're in control and the critical limits are being achieved. But on occasions, on what I would call an unusual activity, you will find that the critical limit is not being achieved. And in these situations, we need to put in place the appropriate corrective actions. So corrective actions are actions to be taken when the result of monitoring at the CCP either indicate a trend towards loss of control, particularly if you're monitoring against a target level, or actual loss of control if you're monitoring against a critical limit. So there are 3 levels of corrective action that we deal with. 1 is bring the process back under control. 2 is deal with potentially non-conforming product. And 3, root cause analysis. And root cause analysis is your investigation. And the result of your root cause analysis will be preventative action. So corrective and preventative action is what we're looking at here. We need to understand what are the consequences if the critical limit's not achieved. Well, we've got potentially unsafe product. What are those 3 levels of corrective action and who is responsible for each level? And we need to verify that our corrective actions have been put in place. It's important that we learn from failures in our HACCP. It does happen on occasions, but it's how we deal with it, which is most important. So what is the immediate corrective action we've put in place? And what are the preventative actions that we can put in as well? And that then brings us to our later stages of our Codex principles. So verification. And verification, by definition, is the application of methods, procedures, tests, and other evaluations in addition to monitoring to determine compliance with the HACCP plan. There are 2 stages. Stage 1 is the validation. Stage 2 is verification. So stage 1, validation, involves, are we doing it right? Before we implement our plan, we need to be very sure in our own minds that our plan is correct. So obtaining evidence that elements of the HACCP plan are effective. Is it correct? Have we identified the correct hazards? Have we left any hazards out? Who was involved in the process? Were they adequately trained? Did they follow the Codex principles? Are the controls identified suitable, and will they control the hazards that have been identified? How were CCPs identified? Was the decision tree used correctly? Are the critical limits the point between safe and unsafe product? Where did they get those critical limits from? Is monitoring going to be capable of detecting loss of control? Is monitoring frequency, is that appropriate? Who is carrying out the monitoring? And will the corrective action bring it back under control? So this is very much the luxury of hindsight, going back and checking your plan before you implement it. And it should be carried out by somebody independent from the main Hassel team. Once we've validated our plan, we take this validated plan and we implement the plan. And this is our everyday product safety, achieved by taking this valid plan and putting it into practice. So we need to consider people and training and equipment, maintenance and calibration of equipment, procedures and records. How are we going to put this into practice and ensure that it is followed on a daily basis? Once the plan is implemented, then we can move to the second stage of verification. So the application of methods, procedures, tests, and other evaluations in addition to monitoring to determine compliance with the plan. So monitoring is your day-to-day control of your plan. Verification is coming back after the event and making sure that we are doing what we said we would do, gathering evidence to demonstrate compliance. And there are 3 types of verification that we follow: audit, data analysis, and sampling and testing. And you should do a combination of those methods of verification. So auditing is a really useful tool where you're going and you're asking questions, you're checking compliance, you're asking people to demonstrate carrying out a task, and you're verifying that your plan is being followed. And again, very useful from a due diligence point of view, that you're not just presenting monitoring records, you're able to go and say, yes, I've got what I call self-governance. I have checked my plan and I know that it's being followed correctly because we've independently audited it. HACCP generates lots of data, so you can use that data to help you. So trend analysis can be carried out, not just things like customer complaints, but how often when my pest control contractor does he raise that doors are being left open? What are my GMP or good housekeeping scores looking like in my factory on a weekly or monthly basis? So there's lots and lots of information that we generate, and even sampling. If you do some end product sampling, then that demonstrates again that your plan is working effectively. And then our final Codex section is principle is documentation and records. So records confirm that we've got safe food being produced. And as I said earlier, record accuracy is vital. Review your records and authorize them. So check them on a regular basis to make sure that they have been completed on time and that the limits are being met. So don't just sign them off to say they're there. Make sure the evidence that they're recording is demonstrating that you're complying. And also maintain things like corrective action records. So when things go wrong, it's just important that you show that you've regained control. So if we look at a plan and there's never any failures, that would, raise a few questions. So if things do go wrong, it's what you do about them, which is most important. And remember, these are part of your due diligence defence. Finally, we've got review. And whilst review is not in the Codex principles, it's important that we carry out regular reviews. So I would do that as a scheduled activity, normally once per annum. But in addition, if there are significant changes in, for example, raw materials or suppliers, ingredients or recipes, or significant changes in your process, maybe you're adding equipment in or taking equipment away, then we would want to do a review. Also, if you've had a number of customer complaints or a trend in some non-conformances, then that would be a good time to review your plan and just check that it remains a valid document. So where does that take us in the future? We need to consider if there are any emerging risks or emerging pathogens that have come through from the horizon scanning stages. And we need to consider our verification evidence and making sure that our plans remain valid. And if there are any adjustments that we need to do, maybe you are selling into new markets, which will have different requirements, for example, different allergen requirements, or you might be developing new products, which are introducing completely new hazards to the range. New equipment coming in as well. So you need to maintain your plan and make sure that it always remains a valid document. That is a really quick overview of HACCP for you today. I can spend several days, and I do spend several days training people on how to implement HACCP plans. So apologies if that feels a little bit rushed, but I hope that has given you some insight, and I welcome any questions from the floor.
Thanks, Lynn, for joining us today and giving us a very thorough presentation on HACCP. And as Lynn said, if anyone's any questions, please type them in the Q&A box at the bottom of the screen and make use of Lynn's expertise and vast experience in this area while she's online. We have a few questions come in already, so I suppose we'll go to them. The first question, Lynn, how often should you update your HACCP plan? Should it be updated every time you change an ingredient or a production method?
Okay, so you need to consider if there are significant changes. So every time you would maybe change an ingredient, you would look at that and see whether that is likely to introduce some new hazards. So any real change, if it's the same ingredient coming from a different supplier, as long as you've done robust supplier approval, you might not need to make any change in your plan. But if it's, maybe they are handling other allergens that the existing supplier was not handling, then that could be introducing new hazards. So you really should be looking at it every time there's a change.
Perfect. We have another question on if someone opens a food truck outside their premises, do they need to re-register and develop a HACCP plan for that separately, or?
Yeah, I mean, that was something, I suppose, during COVID times, a lot of restaurants were coming up with different ways of working within their business. And so it was really important that they consider the hazards associated with that because they may not have the same facilities available within, for example, a food truck. So yes, a separate HACCP plan would need to be written or review their existing one, certainly.
Okay, and we have a question specific to risk assessment. Is the measurement of significance within the risk assessment subjective?
You need to try and keep it as objective as possible, but it is very difficult. So having as much evidence, which is objective, for example, has it ever happened in your premises, or even if it hasn't happened in your premises, has it happened in a similar business? I would look at historical information, not just on your own site, but things that have happened with other businesses. And certainly, just because something has never happened today doesn't mean it couldn't happen tomorrow, okay? So try and keep it as objective as possible, but I realize that it can feel a little bit subjective. And having the balance of people in your team is extremely important, particularly people who are maybe production based. They will have seen things that other people won't have seen. So bring them on board, and people that are very experienced on the site maybe will remember things happening before. Hope that answers that one.
Okay, perfect. And just Lynn, someone saying you mentioned companies having reduced number of CCPs in their studies in recent years. And the person wants to know, is it feasible to have no CCPs at all?
Yeah, I am seeing an increasing number of sites reducing their CCPs down, and they maybe have one or two. And I do know some sites who don't have any CCPs. I think the most important thing is that if you identify them as being significant hazards, that you control them. And how you control them is the most important thing. I personally don't get too hung up about whether they're called CCPs or whether they're controlled by prerequisites, as long as they're controlled. But just be careful that you just don't get caught in the trap thinking, I'll not call them CCPs, and therefore they're not of concern anymore. And you could be diluting your system down, which could have an impact on staff as well, thinking it's no longer important when it clearly is.
Okay, thanks, Lynn. And someone wants to know, can you give examples of steps that are usually CCPs, but in some cases are PRP controls?
Yeah, so sorry, just ask that question again. So they're usually
CCPs, but in some cases are PRP controls.
Yeah, okay. So PRP controls are general site-wide controls. So you may really look at those to say, okay, so something like personal hygiene would normally be a prerequisite control. But maybe you are working at a high care area and you're really concerned about people touching the product, and there's a high risk of cross-contamination from people's hands, and you might decide that hand washing and wearing of gloves, for example, or just hand washing is really important, and you might decide, you know, maybe that's a CCP. I would probably change it into something called an operational prerequisite, but that's sort of a new level that we've introduced as well.
Okay, and we've a question in about, it must be an environmental health officer inspecting an FBO or small or food business it is. They're asking, would it be better to look and walk around the food business first before looking at the HACCP, or the other way around?
Okay. I think taking their HACCP plan, maybe taking their flow, would be a really good starting point when you're inspecting. So actually take that with you and walk that process and see what they've included. So I probably would have a quick look at their HACCP plan, take the flow with me, walk the process and see if it matches what's in their flow, and then see what hazards they've identified. And that's a really good way of inspecting and using it as a central focus for that.
Okay, thank you, Lynn. Someone's asking, do the same rules apply to a home-based business?
Yeah.
Yeah.
So if you're registered as a food business and you can be a food business based at home, you still have to have a food safety management system in place. There are there's flexibility within the legislation around this. So it does talk about a HACCP-based system. So what I've talked about today is what I would call a purist HACCP. There is some flexibility in some models out there that you can use. So we have Safe Catering, which was developed by Southern Environmental Health in Northern Ireland. We also have Safer Food, Better Business, and we also have Cook Safe, which is in Scotland. And those models can be utilised. So they break the jargon down a little bit, but the essence is still there. Okay, so it has to be based around HACCP principles. I know the FSAI also would promote safe catering as well. So it's used throughout Ireland.
Okay, thank you, Lynn. I just have one more question here so far. So if anyone has anything to ask, please do it quickly. Someone's asking, how long HACCP records need to be kept by a food business?
Okay, so depending on the shelf life of your product, it's recommended that you keep them for a year beyond the shelf life of the product. But remember, if your product can be frozen, even if it is a chilled product and you're saying that it can be frozen, you would need to take into account that maybe somebody would have it in the freezer for a period of time and then keep them a year beyond that. Personally, I would keep records much longer. I would be saying maybe 5 years. Some companies even keep them up to 7 years. So you can be prosecuted after a period of time. So I would be cautious of keeping them only for 2 or 3 years. I would always try and keep them for 5 years.
Okay, perfect. That's someone's in with another question. Okay, we've one more. For a small food business, would a food safety management system suffice instead of HACCP?
HACCP is a food safety management system. So if it's based on HACCP principles, then that is okay legally, but it has to be based on HACCP principles. So it has to have identified hazards and has to control hazards, okay? But you can do, I mean, HACCP, it may seem a little bit complicated, but if you go online and look at some of the models that are available there for a smaller business, you can download them from Food Standards Agency and from FSAI. You can download Safe Catering, and it can be applied. You can apply that easily.
Perfect, thanks. That's all our questions then, so we'll wrap up. Thank you again, Lynn, for joining us today.
No worries.